super long section, but at the same time, I'm not in a huge hurry to get through, you know, like a bunch right before break. We're gonna do lessons, but I'm not gonna rush us. So especially on a shorter day, I figure we can just do the first half. Again, we'll do more of this on Monday. So we're gonna learn a couple of formulas today. Now, I'll let you guys know, like, if you, let's say this weekend you're stuck on this, and I don't know if you guys ever do this, but if you Google like how to do something, you're gonna see a lot of different formulas of this. And again, if you look at our book, this is one of those, they use that delta T like symbol. And then again, in talking with Mr. Hatfield, instead of using delta T, we chose to use H. And so, like, again, if you look at our book versus something else online, it looks like delta T is used a lot, but I think it's kind of confusing. So I'm gonna we're gonna use H instead, but essentially this is what delta T is. So it's like the change over time there, the change in time. So if you look anywhere else, that's what it's gonna look like. So we have a formula for this, which is B minus A over N. And I'll explain what those stand for. So that's what H is. So the B is the end point, so it's basically the difference in the X values. So I'm gonna write end like X minus start X. Oh, I should have wrote those there anyway. And then the number of rectangles, or I think the word that we use sometimes is like subintervals. Yeah, I should have wrote them over there.
Or is that like just rectangles or like triangles?
We're just going to do rectangles now. So yeah, good question. So yesterday we talked about like a triangle might make sense in some situations. We're going to stick with only rectangles today. So just rectangles. And then the A and B, again, this is like basically our range of X values. So that's X at the start. And then this is the X at the end. Now the Riemann sum for this, again, we use that summation notation. Again, we're not going to use that notation very much today. Where do I have my general rule for that one? And then it goes up to I'm just going to go K here. So we're going to do whatever that H value is that we find, that's going to get multiplied by the function over and over again. Essentially what that's doing is it's helping us to find the area of all these different shapes, or all these different rectangles. So these first few problems here, we're just finding like either H or N depending on what they've given us. So we're not really doing a whole heck of a lot other than substituting things into this formula. So the B minus A over N will equal H. So again, we're just going to use that right now. So it goes from 0 to 10. So that's what's going to be on the top, is 10 minus 0. Over the number of rectangles, that's the number of groups I want to do. So essentially what this is telling us in terms of our rectangle, if we're talking about a bunch of these different little rectangles here, what we're finding is how wide it is on the bottom, and then up the side is going to be the f of x. So this is allowing us to find the area of that rectangle. So the h is like the width of the rectangle, the f of x is the height, and so we're trying to figure, like this formula is helping us figure out the width. Now, right now, that's figuring out the width is going to be pretty easy, and the reason for that is because this gets harder. We're starting kind of easy there with this. So if you guys want to try the next one here, and the next couple if you want, just be careful, the next one asks about the number of rectangles, or this third one asks about the number of rectangles. I'll give you guys a second. So you're trying to just manipulate a pretty easy formula, and again, it feels like kind of like algebra-ish, but it's because we're going to use it for tougher stuff. Today should be okay. So here we're going to do 11 minus 3 over 4. So this will be 8 over 4, so 2. So the width of each rectangle would be 2 in this case. And then our last one here, they're not giving us the number of rectangles, or we have to figure that out. So if they give you what the h is, you might have to decide what that should be. So we're going to do 7 minus 1. I don't know the number of rectangles, that's going to be my n, and I want that to equal 2. And hopefully the numbers are easy enough to work with that you should tell that n should be just 30, right? So 3 rectangles. And again, right now this probably seems very basic, but we'll end up using it for other things, so being comfortable with that formula is going to be good for us. So we're going to talk about finding those rectangles today. So Becca was asking about, yesterday we did some triangles because they fit the space a little bit better. We're going to stick with just rectangles today. At some point you'll go to like kind of a trapezoid shape as well, because that a lot of times will fit it more closely. You're going to see that the rectangles don't work awesome all the time, and it kind of depends on the curve. So sometimes they're a really good estimation, and other times they aren't. One of the things we mentioned yesterday is the more rectangles we have, the better it is. Now for this, I'm going to show you guys, I'm just going to divide this into, I don't know, like, just kind of make some spaces here. I should try to make equal spaces, I guess. Now again, across the bottom, the h is, from like how wide that rectangle is going to be. And there's 2 different ways we can do this. And depending on the type of the curve, one of them's gonna make more sense than the other typically, or it could make more sense. So a left-hand endpoint, what that means is exactly what it sounds like, is if I draw this I'm gonna draw it using the left-hand side as like my end value. So I'll draw a few of these in to see if you can like visualize what's going on here. So sometimes the rectangle is going to be taller than it, and the other times it's going to be shorter than it, just depending on how the curve goes. But we're going to be consistent about why is that not letting me? So I'm drawing these rectangles in again with a left-hand endpoint. That's on the left side. That's like exactly what it sounds like. And we do that basically till the end. Or like the end of this space we're looking at. Bless you. So if I'm trying to find the area of these rectangles, I'm going to take the H across the bottom. And like H bugs me because it makes me think height, but H is the width of the rectangle. And that's going to get multiplied by the height of the rectangle. And the way we're going to figure that out, so if this is A, this would be F of A, would be the height of it. So how much the function goes like up in that spot. So I'm going to put the value of A in. The next one though then is going to be like A plus 1, A, you know, like, but you're going to notice we never actually are going to use F of B. That's not going to actually get used. So the how far we go on the end isn't going to actually, like, so that last point won't actually get used because we never actually go with that height. We're going to use like basically like B minus 1 here. It's like 1 less than what we previously were at. So this will be then F of A plus 1. We don't have to keep doing this, but just getting the idea here. And it'll keep going. So then a right-hand endpoint is a little bit different. So like just a slight difference. I'll make less spacing this time just to kind of make it a little bit easier on us. Let's just do, I don't know, 4 groups. Do 4 rectangles this time. So this one would be a little bit wider across the bottom, so the H would be bigger in this case. But this time it's asking for a right-hand endpoint. So we go straight up from the right, bless you, and then go over. Straight up on the right and then go over. And again, sometimes a right-hand endpoint is going to make more sense than a left. Usually it really is more about how many rectangles you use. And yeah, you can kind of make a decision about which approximation looks better, which one fits the curve better. And hopefully you're noticing that probably the top one where we had more rectangles, and in that case a left-hand endpoint made more sense. However, when we go find the area for this one, it's going to be the H again across the bottom. And then the height, or like how tall we go this time, we don't use F of A. This one's a hard one to see that because it kind of we're using this side, we're using this side, we're using this side. So we're using like basically 1 beyond A. So we're starting at f of A like +1, and then all the way up to, and we're adding these all together, remember, f of B. So just understand, like that was a little bit of a confusing point for me. Like I was like why are we throwing out one of the, and then once I saw it visually on a graph, it made a lot more sense to me. And so I'll show you guys that on our example here on the back side. Now I just showed you guys, I have like a little graph here. Now if you want your graph to be really specific and great and you want more information than just, we can sketch these. If you like, if it really bugs you that you're not really like, you're not very good at like making a equally spaced graph, I can always get you guys graph paper. But I just, like, just a sketch of this works fine. Like you'll see that I was like, I had all these little sketches I was doing last night when I was working on these, and it's just like, it just freehand works just fine. So it says from 1 to 10, using the following sub-intervals they're gonna talk about. So they gave us this data. Now on Monday, they're not gonna give us the data, they're just gonna give us a function. We're gonna start with the data today. So I'm gonna draw this on our graph here. So I'm gonna go from 1 to 10 and then 1 to 10 up the side. And again, if you prefer to have actual graph paper, but we don't need to be that precise, it's okay if we just, so I just put 10 each way. I'm just gonna plot these points, so feel free to do the same. Stop talking for a minute so you can count. You can connect the dots. We don't really know what happens between these points. It could be like a crazy like zigzag line in between. But if we just connect them, it kind of helps us to see what the shape looks like. Alright, another thing that might be confusing is the fact that there's 9 subintervals. You might just say, why aren't there 10? Because if you're talking about the space between points, there's always like one less. You know, so if there's 10 points, there's 9 spaces between those points. So, 9 subintervals is kind of like probably an easy default. What that means is every subinterval is going to be how wide? It's just going to be 1 unit wide. So h is just going to be 1 in both of these, which makes finding the area a lot easier. Because then all we're looking at is at the value of the function at each of those points. But we should get a different output for both, I think. It's going to be really close, but we should get a different output depending on the right or left-hand endpoint. So if I use a left-hand endpoint, my first rectangle is going to have what as a height? So it's going to have the first value as the height. So I'm going to do 6 plus, because it's 6 times 1, so I don't have to worry about the width. and I'm just gonna basically go down the line. The next one's gonna be 8. So what am I leaving out in this case?
The last one.
The last one, because the last one will never actually use 5 as our height. Does that make sense? Because all these little rectangles, we're gonna go all the way up to the end. The last rectangle is gonna kind of like miss that last value. So I basically, to find the estimation, and again, it's an estimation, this is not a perfect science. This is gonna be our outcome then, just adding all those up. Just 'cause it's the morning and I'm afraid I'll do it wrong, I'm just gonna add it quickly. I got 52. Anyone else? Yeah, I got it. 2 different ways. So if I do the right-hand endpoint instead, and hopefully you're okay drawing on the same graph, because I don't want to take the time to, if you need to redraw a graph every time, it's a little bit of a pain. I'm going to go this way instead, a right-hand endpoint. So this time I'm going to keep out that 6 at the beginning. Does that make sense? So again, the approximation, it's just an approximation again. We just won't use the 6 then. So it's just going to be one value difference. So I believe it should just be 51. So we don't have a ton of time left, so sorry if I feel like I'm rushing a little bit. I always thrown off on these Fridays when we have short classes. What if they said only 3 subintervals? So rather than having all these rectangles, they're saying let's only have 3. So I'm going to break this into different parts. Now if you ever have a hard time deciding how to break it up, you can do 10 minus 1 divide by 3. So they're going to be 3 wide. So 3 units wide is going to be my first one here. And I want a right-hand endpoint. So I'm going to go up to 4. My graph, I just want to make sure. So I'm going to go up. My first rectangle is going to look like this. So it's going to be 3 wide. My next one needs to be 3 wide. And again, I'm using a right-hand endpoint. So my little rectangle there. And then my last one. This one, to find the estimation, takes a little bit more. What do we need to include that we weren't including on the other 2? The what? What do we need to think about that's different compared to the others? The H. Now the H is 3. So that's the width of the rectangle. So we have less rectangles, but we have a wider rectangle. So it's going to be 3 times whatever the height is, which the height in this case is going to be that right-hand endpoint, which is going to be 8 here. So my first rectangle is going to be 3 times 8. My next rectangle is going to be 3 times what? F of, what is that?
3.
Well, we just did, okay, so we just did F of 4, because we did 1, 2, 3, 4. So we went up to 8 here. So that was F of 4, but then I have to do 5, 6, 7. So now I have to do F of 7, which is F of 7. It's 3. And then 3 times f of what? 10. Now we're looking at this line over here. F of 10 was how much on our chart? 5. Now typically with more rectangles, it's not as good of an estimation. We'll see how close we get here. What do we get? That's 24, 24, so we get 48, right? Not too bad. I mean, we're not too far off of those other ones. But it just takes so the rectangles are wider, so that we have to include that base times height, whereas the other ones we didn't have to worry about that because all the heights were just, or the widths were just 1. All right, are we okay?
Yeah.
All right, so the homework that I'm gonna give you guys is a worksheet, but I only want you guys to do the front side. The back side we're gonna save. So it's just the front, which is 5 questions. Now I didn't give you guys any room on here for graphing, so I don't know if you want graph, like the little estimation graph, unless you can just use scratch paper, unless you don't need the graph at all. So some of you guys might be able to kind of figure this out without graphing. I don't know how. I'm a visual person, so I need to graph all the time. Well, yeah, you want to send that one back to Sam too. So if you'd like graph paper, I have some. Okay. Just like I have some, I forgot to copy some. So does anyone want any graph paper? Are you okay with some?
Wait, what is the end